Alright, we have a definition. A critical number of a function f is a number c in the domain of f such that either the derivative equals 0 or the derivative does not exist. So we always find critical numbers first. Now those critical numbers might be or not maybe not, would be a minimum or a maximum, local that is. But if f of c is a local maximum or minimum, then c must be a critical number. What does that mean? Not every critical number is a maximum or a minimum, but if there is a maximum or a minimum, it must happen where the derivative equals 0 or the derivative does not exist. That's how you find that number c. So, first example, example 4, says find the critical numbers. Well, take a derivative. That is 3x squared plus 4x. And you set that equal to 0. Well, it's defined everywhere. So where does that equal 0? That's when x into 3x plus 4 equals 0. So x equals 0 and x equal negative 4/3 would be my two critical numbers. So critical numbers are, if there is a maximum or a minimum, it must happen at one of these 2 points. Part B, if I take a derivative of g, derivative of the top times the denominator minus the top times the derivative of the denominator all over the denominator squared. If I clean that up, that would be 2x squared minus x squared, that's x squared, plus 2x over x plus 1 squared. Well, if I check where does the derivative equal 0, that's when x squared plus 2x equals 0. That's when x into x plus 2 equals 0. So I have x equals 0 and negative 2. And if I check where does g prime not exist, that's when the denominator equals 0. That's when x equal a negative 1. So here I have critical numbers, 3 of them, 0, negative 1, negative 2. Those are the 4 types of problems that we come across. The third is a radical. Derivative of the square root is 1 over twice the square root of x squared minus 1 times the derivative of the inside, which is 2x. So the derivative is x over x squared minus 1 square root. Basically, where does k prime equal 0? A derivative equals, a fraction equals 0 when the top equals 0. That's my first critical number. And where does k prime not exist? That happens when the denominator equals 0. That's when x equal plus or minus 2. So I have 3 critical numbers as well in this problem. If there is a maximum or a minimum, it must occur at one of these values. Now, I take a derivative. This is the 4th type of problem that we come across. That is 1 plus the sine of x. Where does the derivative equal 0? That's when the sine of x equal negative 1. Where does that happen? That's a special case. That happens when x equal 3 pi over 2 plus 2 pi k. So this has an infinite amount of critical numbers. If there is a maximum or a minimum, it must happen at one of these values. How do you find the maximum or a minimum? Local maximum, local minimum, that's going to come up in the next sections. For now, we want to find the absolute. So find the absolute maximum, absolute minimum. So what we know, if you take f of 0, that is 1. And if you take f of 3, that is 2/3 times 27 minus 24 plus 1. That is 18 minus 23. That is a negative 5. So the endpoints are always easy to figure out. The issue happens, if you notice in the previous problem, sometimes the absolute maximum is a local. So I need to find the critical numbers and evaluate those as well. The highest of all the y's will be the absolute maximum, and the lowest with all the y's would be the absolute minimum. So if I take a derivative and see where does derivative equal 0 or not exist, 3 comes down, that's 2x squared plus 6x minus 8. Where does that equal 0? That's when 2 into x squared plus 3x minus 4 equals 0. That is x plus 4x minus 1. So the critical numbers are x equal negative 4 and 1, but on this interval negative 4 is not accepted. So what's f of 1? F of 1 is 2/3 plus 3 minus 8 plus 1. Again, it's right here. That would be 2/3. 4 minus 4 is negative 4. So I get that f of 1 is actually 2 minus 12, negative 10/3. So we have an absolute maximum at x equal, and we have an absolute minimum at x equal. Again, I find the endpoints, and in between, if there is a maximum or a minimum, it must be at a critical number. The highest of the y values is a 1, that's the absolute maximum, and the lowest is a negative 5, that's the absolute minimum. So every time I'm looking for an absolute maximum, absolute minimum, the endpoints I check first, and then I look for the local. The only way to find the local is by taking a derivative. Same deal here. If I take f of negative 1, that is the square root of 3. If I take f of 1, that is also the square root of 3. Well, these are the endpoints. What happened in between? If I take a derivative, that is 1 over twice the square root of 4 minus x squared times negative 2x by the chain rule. So where does f prime equal 0? That's when x equals 0. And where does f prime not exist? That happens when 4 minus x squared equals 0, or x equals plus or minus 2. But since the interval is between negative 1 and positive 1, that doesn't exist. What is f of 0? F of 0 is 4. So we have an absolute maximum at x equal, and we have an absolute minimum at x equal. The highest is a 4, and the lowest is a radical 3 in this case. You could have multiple maximums, absolute maximums, and multiple absolute minimums. If they match, that's not a problem. That could happen. The next problem is a rational, so I'm doing one of each problems that you come across in this book. What is f of 0? F of 0, 0 over 2 is 0. What's f of 4? That is 4 over 6, which is 2/3. So far, this is the absolute maximum, this is the absolute minimum, but what happens in between? If I take f prime of x, derivative of the top times the bottom, minus the top times derivative of the bottom, all over the denominator squared, that's the quotient rule. F prime of x would equal x minus x cancels out, that's a 2 over x plus 2 squared. So the only critical number I get, f prime cannot equal 0, but f prime not exist when x equal a negative 2. Negative 2 is in that interval. No, it's not, so there it is. We have an absolute maximum at x equal 4, and we have an absolute minimum at x equals 0. Of course, we have an absolute maximum of 2/3 at x equals 4. We have an absolute minimum of 0 at x equals 0. Now, you could graph it if you want, but the graph is for your own reference. You can never quote the graph and say, oh, look, based on the graph, this is the maximum, this is the minimum. How about this problem? For the same deal, if I take a derivative, now what's f of 0? F of 0 is 0 minus cosine of 0 is 1, is negative 1. F of 2 pi is 2 pi minus 1, right? That's roughly 6.28 minus 1, about 5.28. So far I have two values. If I take a derivative, that's 1 plus the sine of x. Where does that equal 0? That's when sine of x equal negative 1. Again, we did that already. That's a special case. So my critical number happened to be x equal negative 1. And negative 1 is not in that interval. So pretty much we have an absolute maximum at x equal, you know what, I'm going to change the problem slightly just to make it more interesting. Oh wait, I messed up. that happens, we have a critical number of 3 pi over 2, right? 3 pi over 2 is in there. I messed up, my mistake. So if we take f of 3 pi over 2, that is 3 pi over 2 minus 0, that's roughly 4.71. So we have an absolute max at x equal, and we have an absolute minimum at x equal, well, the highest of all of these values is a 5.28, so at 2 pi, and the lowest of all of these values is -1 at 0. And that's the idea of this section.